Hello students, welcome back. So now we are going to be talking about swarm plots. Now swarm plots, they help you avoid overlapping data points. That's one of the key feature, one of the powerful thing about these swarm plots. And also they tend to be idle when you have a small data set, maybe like 5,000 or less data points. So in this case, I'm importing my tips data set. I'm printing out few records right here. So this is my few records of tips data set. So let's do the swarm plot. All you have to do is just call swarm plot and you specify your tips data set and you specify your column. That's all you have to do. And in this case, this is how it looks like. So each one of these dots right here, that's your data point. So anytime in there, you can see that there's going to be a lot of overlapping over here. So in order to prevent that overlapping from happening, these points, they actually go in this direction and some points they come in this direction. So this way it can actually avoid overlapping data points. Let's compare swarm plot with KDE plot. So if you look over here, you can see that most of my data points over here. Let's understand this through a KDE plot. So in this case, I actually have a swarm plot. My data equal to tips and my x equal to total bill. And I'm also doing the KDE plot, your data equal to tips and your x equal to total bill. And when I plot them right next to each other, I mean right below one below the other, you can see that most of my data is over here. And so you should see your KDE go up over here. So you can tell that your data is mostly distributed in this range between 10 and I would say 25. So this would be your 10 right here. This is your 10 and 25 would be somewhere over here. So you can see that you have a lot of dots over here, a lot of heavy data points over here. So most of the data is in between 10 and 25. You can make these types of observation by looking at these graphs right here. Now, suppose you want to separate your total bill by day. You can do that too. In this case, I specify my X will be my day. That is how I want to separate. So this is my categorical right here. So let me write categorical. And this is numerical data right here. So when I plot this, you can see that it actually splits that, it actually separates that based on days. So for Thursday, this is my total bill. For Friday, this is the total bill for Saturday and Sunday. And you can see that on Friday, not many people they came for on Friday. And for Saturday, you can see there's a large number of people came on Saturday, and also a lot of people came on Sunday. But on Friday, there were not many. You can draw these types of conclusion. And now we're going to plot your swarm plot and violent plot right on top of each other. So this way you can see how they look like and compare them with each other. So in this case, I'm calling inbuilt method swarm plot and my column is going to be tip column. That's the one I'm using. For violent plot, I'm also using tip right here. So when I plot it, this is how it looks like. You can see that each one of these dots, they represents your data points, and you can see that your curve gets higher, like basically your density gets higher over here because you have more data points over here. Now let's say you want to do the tip by time. You want to separate that based on the time. If you recall, your time was lunch and dinner, so I'm doing it for swarm plot. I'm also doing it for violent plot. Let me decrease. Okay, so I'm also doing for both of them. So coming down back over here, when I plot this, you can see that it does it for lunch and for dinner. So you have more data points right here. So that's why your violent plot actually goes in this direction. Also, same thing over here. More data points. So your violent plot actually goes like this. And now I will show you how you can put swarm plot and box plot on top of each other. So in this case, I'll be using total bill. So call the box plot, specify your y equal to total bill, call your swarm plot, specify your y equal to total bill, and then you put this title box plot and swarm plot. When I plot them, this is how it looks like. So here you can see that this one right here, most of my data is heavily concentrated in this region right here. So if you remember from your box plot, the session that I explained and that I took a while back, you would understand that if you remember, this is your Q1. And Q1 means that this is the point where 25% of your data falls below that. In other words, 25% of your data is in this region. That means these number of points right here, they are 25% of your total points. If you remember Q2, this is your Q2. That means 50% of your data lies below that. That means these dots right here, if you count the number of dots, you're gonna see they will be like 50% of your total number of dots. And likewise, this is your 75%. So 75% of your data lies below this. And now let's do total bill by day. So I'm calling box plot first. So in this case, specify your x equal to day. So this is going to be your Thursday, Friday, Saturday, Sunday, and my y is going to be total bill. Also calling swarm plot. So x equal to day and my y equal to total bill. And now let's plot them together. So when I plot them, this is how it looks like. So you can make some interesting observation over here. For example, for Saturday, that would be this right here. You have a lot of data points. A lot of people they came for Saturday. Not many people they came on Friday. Also, if you notice, A lot of people, they gave a high total bill on Saturday, so people paid more money on Saturday, and on Sunday not so much. So you have more data points for Saturday, and you don't have as many data points for Sunday compared with Saturday. So but definitely Friday you do not have a lot. Friday you have less data points, so you can draw these types of conclusion by looking at these dots right here.